go for the next question. Long answer type question in temperature and thermal expansion of heat. The question is, describe with necessary theory the specific gravity bottle method to determine the coefficient of apparent expansion of a liquid. And tag to this one problem is given. The problem is, what volume of mercury must be placed in a glass flask in order that the volume of flask not occupied by mercury may be the same at all temperatures. Given alpha for the glass is 0.00009 per degree Celsius and the value of gamma for mercury is 0.00018 per degree Celsius. We can divide this question into two parts. The first part is the experiment. This experiment carries 6 marks and the problem tagged to this carries 2 marks. What is specific gravity bottle? A bottle whose volume is constant at all temperatures. That is called a specific gravity bottle. The volume of the bottle is constant. Now how you can measure the change in volume of a liquid that contains in a bottle? The volume of the bottle is constant means when the liquid is heated, if the volume increases, then what happens? The liquid will be expelled. That means since the volume of the bottle is constant, the increase in volume of the liquid is measured in terms of the mass of the liquid that expelled. This is the principle what we are using to determine the apparent expansion of a liquid using specific gravity bottle method. Have you seen the specific gravity bottle in lab? Yes, this is specific gravity bottle. The volume of this bottle is around 50 ml. It contains a fine bow as you are seeing. This contains a stopper and this stopper contains a fine bow as you are seeing. Now the aim of this experiment is determination of the coefficient of apparent expansion of a liquid using specific gravity bottle method. Now the experimental procedure is an empty, clean and dry specific gravity bottle is taken and its mass m1 is determined using common balance. The liquid is filled in the bottle. Its mass m2 is determined at temperature T1 degree Celsius. Now the bottle with the liquid is suspended in water bath up to its neck. See here, the bottle will be suspended like this up to this neck. If the temperature of the bath is raised to T2 degree Celsius, both the liquid and bottle will expand and oozes out from the stopper and it is removed using blotting paper. After the expansion is completed and it is cooled at room temperature T1 degree Celsius and mass m3 is determined. Now in experiment we are measuring the mass of the liquid at T1 degree Celsius m1, that is equivalent to small m2 minus m1. The mass of the liquid at T2 degree Celsius capital M2, that equivalent to m3 minus m1. The rise in temperature T degree Celsius, that is T2 minus T1 degree Celsius. Now using this data, the apparent expansion of the liquid can be calculated using the formula, the mass of the liquid expelled by mass of the remaining liquid into temperature change. That means gamma equivalent to m1 minus m2 by m2 into T. This m1 minus m2 is nothing but mass of the liquid expelled divided by m2 into T. m2 is the mass of the liquid that remained in the specific bottle and T is the temperature difference. Now using this formula we can determine the value of gamma A. This is the experimental procedure or description. Now we go for the theory related to this experiment. The experiment carries 6 marks. In this, if you write the procedure of the experiment, you get 3 marks, and the theory related to this experiment gives you 3 marks. Now theory related to this experiment is, let ρ1 be the density of the liquid at initial temperature T1 degree Celsius. Let ρ2 be the density of the liquid at final temperature T2 degree Celsius. Then what is the volume of the liquid at temperature T1 degree Celsius? V1 equivalent to m1 by ρ1. We are taking M1 is mass of the liquid at T1 degree Celsius. You consider this is equation 1. Similarly, the volume of the liquid at temperature T2 degree Celsius, the volume equivalent to mass by density, that is V2 equivalent to M2 by rho 2, we consider this is equation 2. V1 and V2 are also equal to volume of the vessel at temperature T1 degree Celsius and T2 degree Celsius respectively. Because the liquid fills the vessel fully at these two temperatures. At these two temperatures, the liquid fills the vessel fully. Why? Why? Because already we discussed the specific gravity bottle is a bottle whose volume is constant. The volume of the bottle is not changing. The volume of the liquid changes. But what happens to the increased liquid? That will be expelled out. Now at these two temperatures we can write V2 equivalent to V1 into 1 plus gamma T. The relation between the densities of the liquid is rho 1 equivalent to rho 2 into 1 plus gamma R into T, where gamma R is the coefficient of real expansion of the liquid. Now, from equations 1 and 2, we can write V1 by V2 equivalent to V1 by V2. This is nothing but V1 is M1 by rho 1, V2 is M2 by rho 2. This is equivalent to V1 by V1 into 1 plus gamma G into T. This is equivalent to M1 by M2 into rho 2 by rho 2 1 plus gamma R into T. Now on simplification we get M1 into 1 plus gamma G into T. This is equivalent to M2 into 1 plus gamma R into T, or M1 plus M1 gamma G into T. Here gamma G is the volume expansion of the glass. Gamma R is the real expansion of the liquid. M2 plus M2 gamma R into T, or M2 gamma R into T equivalent to M1 minus M2 plus M1 gamma G into T. Now dividing both sides by M2 into T, we get gamma R equivalent to M1 minus M2 by M2 into T plus M1 by M2 into gamma G. If the expansion of the vessel is not considered, why? Because already we told the volume of the vessel is constant. That means if the expansion of the vessel is not considered, we can take gamma G equivalent to 0. Therefore, gamma R reduces to gamma A. This you can write it as gamma A equivalent to M1 minus M2 by M2 into T. Now here M1 equivalent to M2 minus M1. If you substitute M2 equivalent to M3 minus M1 and T equivalent to T2 minus T1, we get gamma A equivalent to M2 minus M1 minus M3 minus M1 by M3 minus M1 into T2 minus T1, or this is equivalent to M2 minus M3 by M3 minus M1 into T2 minus T1, where M1 minus M2 is the mass of the liquid expelled and M3 minus M1 is the mass of the liquid remaining. Therefore, gamma A equivalent to mass of the liquid expelled divided by mass of the remaining liquid into rise in temperature. This is the value of gamma A. Using this we can find the value of gamma A, that is the apparent expansion of the liquid. The third part of the question is, the problem is what volume of the mercury must be placed in glass flask in order that the volume of the flask not occupied by mercury may be the same at all temperatures. In this it is given the gamma value for the mercury is 18 into 10 power minus 5 per degree Celsius, and the alpha value for the glass is given as 9 into 10 power minus 6 per degree Celsius. Now given gamma Hg is 0.0018 per degree Celsius and alpha for glass is 0.000009 per degree Celsius. Now what is given in your question is, at some temperature mercury occupies some volume in the flask. When you heat this, the volume that not occupied by the mercury, that means empty space, should remain constant at all temperatures. How this is possible? When you heat it, if the expansion of the mercury is equivalent to expansion of the glass, then only this is possible. That means expansion of the container should equivalent to expansion of the mercury. If this is possible, then the empty space above the mercury at all temperatures remains constant. This is the principle what we are using in this problem. Now from this we can write gamma Hg into VHg. This is the expansion of the mercury. This should be equivalent to gamma G into Vg, or the volume of the mercury equivalent to gamma G into Vg by gamma Hg. And this is equivalent to, given the value of alpha equivalent to 0.00009 per degree Celsius, therefore the value of gamma for the glass equivalent to 0.00027 per degree Celsius. Similarly, the value of gamma Hg, this is equivalent to 0.00018 per degree Celsius. If I substitute these values, I get VHg equivalent to 1 by 7 Vg. Hence, 1 by 7th volume of the vessel is filled with the mercury. Then, on heating, the volume of air inside the container, that will remains constant at all temperatures. This is the problem. If you do this problem, you get 2 marks.